You're listening to 9 Plus, a research podcast from SETU Ireland. Hello and welcome to 9 Plus, the podcast which explores some of the research being carried out in the South East Technological University of Ireland. My name is Rob O'Connor and I'm your host. In this episode, we're talking about the exciting area of bioplastics, the circular economy, and turning the waste of one process into the raw material of another. My guests are two SETU faculty members based on the Carlow campus. Adriana Cunha Neves is a biochemist and David Culliton is a materials engineer. Together, along with others, they've been working on how to create new biodegradable plastic materials out of the discarded materials from other processes, such as waste products from the fish industry or even used up brewer's grain. It was a fascinating talk, and the enthusiasm that both David and Adriana bring to the conversation is truly infectious. You can hear straight away at the massive potential for this kind of work. There's some links in the podcast description for places to discover more about their research or how to get in contact. But for now, let's meet Adriana and David.
My name is Adriana Cunha Neves, and I'm a lecturer in the Applied Science Department here in SETU Carlow.
My name is David Culliton. I'm a lecturer in engineering in Carlow and I'm co-director of EngCore.
Okay, so we're here today to talk about bioplastics and some of the work that you have done in this area, you and others as well. It's not just the two of you.
Yeah.
Although I'm not trying to diminish your work, but you're very mindful, Adriana, that there is a team
Absolutely.
involved. Could you explain, first of all, what are bioplastics?
Bioplastics is any material that is coming from a renewable source, so any plastic material that comes from a renewable source or that is possible to compost or both of them together. So if you have a plastic that is compostable but comes from a petroleum-based source, it's still considered a bioplastic. If you have a plastic that comes from some organic material that is renewable, but it's not fully compostable, it's still called a bioplastic. The ideal bioplastics are the ones that join the two characteristics, so they're both biodegradable, but they are also they also come from a natural source.
Okay, so why is that important?
This is extremely important because many of the bioplastics that exist in the market at the moment are one of the two things. And I believe that the consumer thinks that they are getting the best material for the environment. They're being very environmentally conscious when sometimes they are buying something that is labeled bioplastic, but they might not be doing great to the environment.
And would you agree with that description, David?
Generally, yes. I mean, sustainability is the foundation of modern engineering programs, and for sustainability, it has to be a source that is renewable. And the problem is that commercial interests can use words to describe materials but are using them inaccurately because they're facilitated to do so. And what we're trying to do is create a real option in this sphere. So
would I be right in saying that if I was to set the scene, is that you're talking about plastics, materials, you buy some product in the shop, whatever it is, right? A packet of sausages, okay? And it's encased in maybe a hard plastic and a soft plastic, and it just, when you're finished, when you've cooked your sausages or whatever, this plastic goes into the bin.
Sure. And
it might be recycled, but it might not. And if it goes to landfill, it will just take thousands of years to degrade. And Adriana, you're nodding your head.
Yes, absolutely.
Okay, as opposed to what you're talking about is something that might degrade in how long?
6 to 8 weeks is what we are proposing. And that's a very specific timeline, and it's particularly important because as per our work, we spoke about these new materials to composter companies, and this is a good timeline for them. They want a plastic material to be compostable at the same time, more or less, that paper will be compostable, so they can have a quick turnaround and sell their compost in a fast way. They don't want a material that will degrade in much longer than that, because then they can't sell compost with little bits of plastic that are not fully degradable. So that 6 to 8 weeks is a very good timeline for the plastics to compost.
And is that achievable?
It is achievable. All our plastics are degradable and visually degradable in 6 to 8 weeks.
Okay, now you brought a little box in of some of your plastics.
Yes.
We might just go through these as examples. Now, okay, this is a podcast, so we can't see them, so I'm going to try to describe them. So this one here that I'm holding up feels like a tough plastic. It feels like something that might be a transparent window in a tent. Like, it's quite tough.
Sure. Yeah.
So what would the context of this be?
Basically, all of our plastics can get different characteristics depending on the formulation that we use. At the moment, we do have enough expertise between myself, David, and other people in the team that allow us to generate this thicker plastic, like the one that you're holding, as other thinner ones or more elastic looking ones, like that one.
So this one I'm holding here, it feels quite stretchy. It's a bit tacky as well. So I'd say it might cling to surfaces. Mm-hmm. It's quite thick as well. It feels almost kind of like a membrane.
Yeah.
And this one here is very tough. This one is quite these bits in it. Again, that feels very tough. I'd say that could take a lot of
abuse.
Yeah. And then there's one here that's quite hard. Actually, I'll be honest with you, if you didn't tell me, otherwise you might be confused for thinking it's like bark from a tree or something like that. So it's quite hard compared to the other ones.
So that's exactly what I was trying to come across when I brought this, was that we can now generate different types of plastics with different physical characteristics, and the reason why it's so important that we can produce different types of bioplastics is that we want to have high impact in society. So we want these to really be uptaken by different industries, different stakeholders, and that's why we join forces, science and engineering, because from the engineering point of view, the material, the physical characteristics and mechanical characteristics of the material are very important, and that's what is going to give the applicability to the plastic. So it's very important for us that we can do different types of bioplastics, that we can get high applicability, different applicabilities, and at the moment we are in a place that we more or less are able to produce whatever the stakeholders want or need for their own application.
So based on what you're saying then, Adriana, is this why you have a material scientist here, or engineers, or designers, or other people involved in the project? Because, is it a project? Is it a discipline? It's very actually hard to describe it. It's David.
It's a passion.
It's a passion. A passion project. Right. So, explain why it takes a multidisciplinary team to produce something like that hard plastic there that kind of is like bark.
Yeah. Actually, the whole point of developing new bioplastics was because we believed that was what it was lacking. There was a lack of interdisciplinarity in the development of plastics, and that's why the plastics were not being uptaken by the market. When we first started with bioplastic projects, we got it. I got a small grant from SFI, and we decided to look at what are the needs of the stakeholders in the generation of bioplastics. There are actually lots of bioplastics being developed at the moment, very interesting ones, but the stakeholders are not being involved in the process of making them, and that is reducing the uptake of these materials. So I joined with Brian Casey, that you already had in this podcast, Martina, a colleague that is working elsewhere at the moment, and they are designers and material scientists. So we try to approach it from the design point of view and see with different stakeholders. We contacted many different stakeholders to see what do they need. And they started saying, what are the characteristics? So we need a plastic that is really strong. Others, we want one that degrades really fast. We want something that is hydrophobic or hydrophilic or thicker, thinner, whatever. And we started to try to develop this in the lab. Now, I'm a biochemist, so I needed someone to come on board and tell me, how do we measure these characteristics? And David Culliton has a lot of experience dealing with materials and testing materials, so I contacted David, and you can...
Yeah. So let's say, you're saying you're a biochemist. I'm not a biochemist. My knowledge of kind of those kind of sciences is fairly limited. So if I say something incorrect, please do pick me up on it. So would you be looking at things like the chemical structure, the molecular structure of these materials as you wish to create them? But then you might want to go to David for this kind of, I want something that can hold water or whatever it might be. So David, where do you come in? What do you do in this instance?
Okay, as a precept, the plastics are a problem generally, recycling, non-recyclable. So, society understands this. The advantages of plastics, though, are humongous. You can design a plastic based on a single molecule. You can generate a vast array of different properties to deal with different societal needs. So it's not just looking at sustainability, it's also looking at applicability and usability. And I suppose everything is benchmarked on what's available right now. The plastics that are currently being used, like polyethylene plastic bags and stuff, we have to be able to replicate those properties in those applications to demonstrate that the plastics we're creating are interchangeable with these current plastics. And so we're looking at the mechanical properties, we're looking at even down to tactility and textures, and so that we can seamlessly replace one with the other. And the end user doesn't really see any difference, but understands that there's a massive difference.
Okay, so if I go back to my example of buying a packet of sausages, right, I expect there to be a hard plastic, or a kind of a semi-hard plastic, and then maybe a transparent film so I can see the sausages, right?
Yes.
Whereas if you just have a basic generic bioplastic that would be used, like say for example that kind of tacky membrane one that we pulled out earlier, that's kind of red in colour, that would not look appealing to me if I was looking to buy a packet of sausages or a bag of oranges or whatever it might be. Okay, is the idea then you can go in and say, right, this is what the product currently uses, how can we come up with an equivalent using a more environmentally friendly, biodegradable and sustainable bioplastic? Is that right?
That's basically it, yeah. Okay. So that the user doesn't really see any change or any different in their experience, but that when they go to discard the packaging after they've used the product, then the sustainability comes into play, the compostability comes into play, and the fundamentals of the plastic changes come into play, and then they can appreciate the difference, because suddenly they're not filling their bags, their bin bags, with lots and lots of plastic packaging. That packaging is going somewhere else.
Okay, so now again, I don't know anything about waste management either, other than I have a house. Obviously, I live with my family and blah blah blah. Okay, and I have a lot of kids, so at the moment we have the amount of putting stuff out in the bins every week. Okay, and we try to do our best with recycling and etc. etc. What you're saying to me here would lead me to believe that even if I put a bioplastic in the wrong bin, it kind of wouldn't matter, because it would degrade itself. Or you're giving me a kind of a...
Well, okay. I mean, it's kind of... It's like putting grass cuttings into your landfill bin.
Right.
It's not preferred for the landfills because it creates gases and it creates problems when it's in the landfill. But there are, Adriana's from Portugal, and in Portugal you have particular bins that allow you to use to deposit green waste. And these recyclable plastics could be, we don't have that system in Ireland just now. I know they're talking about it, but if we did, and if we advanced to proper compostable plastics, we would be kind of compelled to have this service for people, because people in apartments don't have the opportunity to put bins in their compostable bins in their back gardens. So this kind of service would be a necessity, and would generate additional industry in Ireland, and we would be then replicating what's around Europe. So as a society, we would be advancing in a positive direction.
Yeah, I can see how that makes a lot of sense. So it does come back, though, to a more societal change. It's not just about the product or the technology. It's also about the use of the technology, the adoption of the technology, and the acceptance of the technology. And have you, Adriana, you're nodding away there, is this something that you have had much experience with, about the acceptance of this?
Absolutely. We actually, with that first bit of funding that kickstart all these projects, it was all about acceptability, and we did a long survey here in Ireland, and we realized a few things. We realized, first of all, that people, particularly consumers, don't really understand terminology around bioplastics. So when you say this is a bioplastic, people don't know what it means. They know it's better for the environment than single-use plastics, but that's pretty much it. They're not very aware of where to discard things. And other things that we figure out about this acceptability is that the industries don't want to do a big change to their processes to replace the plastics that they have, but they are actually available for a little bit of change. They because there's a lot of pressure from the European Union to all the industries to become more sustainable. Changing, they are open to change a little bit to be able to meet those sustainability goals. So it's not that the industry doesn't want to change anything and is not open to bioplastics. The industry is open to bioplastics, different types of industries, from producers, from transporters, to final users. But they just need something that will work for them as well. So there were a lot of work done. There was a lot of work done on understanding how is our solution gonna actually make that change, and that's why we are trying to focus not only in developing the plastic, but also understanding how can we make the general public to accept it, to understand what we mean by bioplastic, and to take that, and that where it comes in play. Events like we've been doing for these last months. That is the SPAC event, or other events that we've been doing with industry and this type of thing.
So I was looking through some of your publications before we started recording. I see one from 2020 with Brian Casey is one of the co-authors, and it's acceptability and societal impact of the introduction of bioplastics as novel environmentally friendly packaging materials in Ireland. So I'm assuming this is exactly what you're talking about here. So it's not just about the stuff, we've created the stuff. Now how do we how do we get it into people's hands or shopping trolleys or whatever it might be? I'm using shopping trolleys, but it's not just food packaging. It's so many more things. Yeah. David, you're nodding there. Going,
yeah, well, it's just that I suppose the shopping trolleys is where people are most familiar. You know, that's what they're looking at, and it's the single-use plastic. The COVID pandemic raised that as a serious societal issue. We saw masks discarded all over the place, and that linked back to people dumping plastics into their bins. People became more conscious of what they were doing, but there aren't alternatives. And what we're trying to do is give that alternative. Originally, we were, the circular economy is a big talking point at the moment, and one man's meat is another man's poison, and it's linking different industries together, inputs and outputs. We were looking at fish waste. And that's kind of where some of that acceptance comes in. Would people use a plastic that was made from fish waste? We did a lot of kind of introspection and a lot of surveying to some of the stakeholders. We demonstrated that the plastics had no odour, for example, which is a key thing. Nobody wants to buy sausages that smell the plastic
or
fish. Or bread or
clothes or something, whatever.
Absolutely, yes. So we demonstrated that it wasn't an issue, but still, I suppose there's a subconscious concern for people. It's made from fish, then does it not stink of fish? So there's a certain amount of resistance. So there's a transitionary period in all of the introductions of new products. This is a particularly massive transition for the industries and for society generally. So there's a lot of conversations that need to be had, and there's citizen science and engaged research which will address a more wholesome, I suppose, or holistic approach to this kind of research, which is critical to its development and it's the acceptance of the results.
There's another publication here, The Effect of Different Starches in the Environmental and Mechanical Properties of Starch-Blended Bioplastics. You're both co-authors on that. Is that this kind of stuff? I'm not saying starches is fish. Maybe it is. I don't know.
Yeah, well, actually, it's... we started with the fish waste, but at the moment we are using very different waste materials to produce the bioplastics. As you can see in here, there's examples that I brought. The one that you said that it looked like bark, was it?
Oh yeah, I just said bark, but I mean
this is a very interesting material that comes from the waste from the brewing industry in Ireland. Oh, wow. So brewers spent grain. This was a project that a final year student made in the brewing distilling course here in Carlow, and we were able to polymerize it in that material that we're hoping to bring back to the brewing industry. There's other that has a leather feel to it, and pieces of leather.
This
that one,
yes.
That comes from the leather industry, waste that they have as well, and is again another undergraduate project student from design actually that is working on that. So again, the interdisciplinarity. But one of the things that we always have to add, or mostly have to add, is some starch material, and is
that to give it structure?
To give it a structure and to do that cross-linking between the molecules. So starch was a problem because most other bioplastics that exist come from potato starch. Potato is a food source,
yes.
So we don't want to be generating potato starch to make plastic when it's actually a food source. So we don't want to create a problem with generating a solution. So we have a postgraduate student looking at different sources of starches that are actually more sustainable, that will actually help the environment because they're saving our ecosystems by producing these starches, and that they're not being used for anything as a food source, so they can then be used for the bioplastics. So at the moment, all components of our bioplastics are sustainable. That's what that publication is from, is to check different starches would make in terms of what implications would it have in terms of mechanical properties of the bioplastic, and that was some of the findings that we got are in that paper. But again, many different waste products. If anyone is listening to the podcast and has an industry with a waste problem that they don't know what to do with a waste stream, a byproduct, maybe contact us and we'll try to turn it into a bioplastic.
Yeah. So again, it's this circular economy thing. Yeah, there's an interesting example. Now it's not in bioplastics, but there's in the Arc Labs Research Centre in the Walton Institute, just down there, just by the Waterford campus, and there's a supercomputing centre there. Lots of machines and servers and etc. But what they do is they generate a lot of heat, but they draw the heat off that. And that is used then for the energy for the building, which is quite interesting.
Genius,
now that was a new building, so they were able to actually do it that way. But that way, it doesn't have. They're not running cooling, using energy to run cooling to get the heat. They're drawing it off, and it becomes more of a circular thing. I'm not describing it very well because I didn't set it up. I've just seen it demonstrated, and I went, "Ooh, that's cool."
Yeah, I mean, it makes sense. They're not using electricity to cool on one side of the building and then more electricity to heat on the other side of the building. They're just transferring the energy from one to the other, which is a great idea.
Right, so let me go back a bit further. We'll take a little kind of a sidestep as to where you both kind of come to, or where you both. So we're talking about this. I can genuinely see how this can change the world. Okay, in a positive way. Okay, and I'm not trying to blow smoke at you either, or big you up too much. Don't worry, I'll insult you in a moment. I'd like to know how you both get into this, because I'm sure you don't sit around and you're saying, you're filling out your leaving cert. What do you want to do? I want to make bioplastics and change the type of materials that some fella buys sausages in. So how do you get to this point? So let's say you're going into third level for the first time. What are you studying? What are you getting into? So Adriana, we'll start with yourself.
Yeah, well, in college back in Portugal, I studied forensic science, and I worked doing autopsies for a while. So I'm a biologist, as my background is biology. But then I came to Ireland to do a PhD, which was more biochemistry, and that's more applicable to food, to the food industry, looking at bioactivities of food. And in there, I had contact with waste materials of different industries, particularly the fish industry. And I came across my favorite protein. And I know this sounds so nerdy to have a favorite protein. I wonder how many people have favorite proteins, which is gelatin. Gelatin has so much potential. It's such an interesting protein, and it was used for this and that. But when I came here to Carlow, I had the idea of using that gelatin as the base for this type of polymers. The fish gelatin hasn't been used before for creating bioplastics, so I gave it a try. I got a nice material, and I liaised then with David to try to analyze the material from a more mechanical point of view, and things started, and with Brian Casey as well, from the needs of industry and all that, and things started from there. So it wasn't that I had a passion for plastics, I'm environmentally conscious, and I had this idea of, let's use this to do something that might be useful for society. I am truly passionate about science. I love science. I get a great kick out of doing research and generating new things, and so that was just the way that it went from there. Yeah, that was it.
I don't want you to apologise for being a nerd, because we're all a bunch of nerds, and it's I can see the way you describe it and the enthusiasm that you describe it means you genuinely do care about this stuff. You do care, and that's, I think, when somebody's passionate about something, it comes through. I also think it's interesting that you went from forensic science, where many people would consider a sexy area, to I don't
Are you saying that bioplastics are not sexy? What do you mean?
Yeah. Well, that could be another brand. That could be another application. But there was something in your research. You just saw this fish product and went, ooh, I wonder is there something we can do with this gelatin that maybe hasn't been done before, and it just sparked your interest.
That's exactly it. And I suppose, again, I'm a scientist more than being a biology or a chemist or a material scientist, that what I've been doing lately. I'm still a scientist, and I love science, and I love discovering new things. I still love forensics. So it's just doing something that is different. And in fairness, we don't think that we're going to solve the problem of plastic solution with these plastics, but we think that if we contribute a little bit, we're doing our role as a scientist, aren't we? So everyone can contribute a little bit with whatever they have. We hope that we can contribute a little bit for the environment, the problem of plastic solution with this, but we're very open to other solutions and more ideas and more interaction with people, and other scientists bringing other approaches from different areas. I think that's what is actually going to do the job.
David, your own background. So how did you end up in this in bioplastics? So you said you're a material science engineer.
I'm an engineer. Yeah, I'm an engineer. Yeah,
right. And you're in aerospace engineering, is it?
No, mechanical.
Oh, mechanical engineering. Okay, so mechanical engineering to making things out of fish gelatin.
Yeah. Okay. I'm. It's traditional engineering, but I've always had a substantial interest in the material side. My major was product design, and it's always been a passion of mine. Surface degradation, wear, coatings, that kind of stuff, and materials development comes second nature as part of that. Paints are based on organic systems, but when you work with paints, you're basically swimming in solvents all the time. So there was always a huge interest in there should be a better way to do this. Then when I did my PhD, I was working in thermal coatings and then sol gels, which are almost plasticized ceramics, in a way. And I was developing something new. I was developing or optimizing techniques for combining these two very disparate systems together to protect surfaces. So when I moved to Carlow and met Adriana, there wasn't really a huge amount of discussion. It was already something, materials, that has been a passion of mine for a long time. And this was an opportunity to do something very diverse, from just surface coatings. This was bulk materials. So, and that's always a huge challenge. That's a big difference.
So when you're creating these, I mean, how do you actually make this? Is that a stupid question? Is it like
no? But it's a secret, so we can't exactly say how do we make it exactly. But what it's really how we do anything in biochemistry is a recipe. We put the ingredients together, and we focus on, again, sustainable ingredients that are that are a problem in some other industry. We put it together to polymerize it, and it dries out to be that. The process at the moment is a bit time costly, but we already have ideas to make it more applicable to industry, faster, let's say more economic or efficient.
Would it be correct in saying that, okay, so you're making this in a lab, so the first one is the most expensive one, but I mean there's economies of scale. If this was being mass produced, the price would come down. Would that be fair?
Yes.
Okay. Yeah.
Of course.
Yeah.
And is it possible to mass produce sustainable, degradable materials using waste from other processes?
Absolutely, it is. There might be some little changes in the process itself that need to be made. But again, we are working on this. We have ideas. We are just waiting for a bit of funding to come for us to test it in a larger scale. And once that is, we are confident that it's actually applicable in a larger scale.
Yeah, I suppose one of the main stakeholders we've had discussions with would have been industry, production companies, and they have invested huge amounts of money in the equipment that they use. So they're not really looking for a replacement raw material that is so different that they can't use their injection molders or their extrusion and blow molding machines. So they want a raw material that basically they can just take one type out and put this in. That's not as easy done as that sentence might suggest. So there is a lot of kind of research that needs to underpin the development of a raw material that is industrially applicable.
Okay.
And we're currently involved and engaged. We have a postgrad student who is working in that area. But if you're limited by resources, you're investing time. So if we had 3 students working in that area, you would get it done in a third of the time. And that's not even true because it's economy of scale. So if you had 3 people working together, they would work together, so they would resolve problems much more quickly. So.
But what you say about reusing the existing machinery, I suppose that isn't that the key thing? Because as we talk about anything to do with the environment, if we were starting from a blank slate, well, we could do things so much better. But we're not starting from a blank slate, and you have to kind of work with what you have, for good or for ill. Okay, and I'm not going to make a value judgment on that. But we have if company has spent millions or billions on a particular type of machinery and process, they are not going to have the inclination to just throw it all away and start something else.
No, they're not. And that's where engagement with stakeholders becomes so important, because it's not just the end user, it's not just the consumer, it's the manufacturer of the food and the packaging that they use, and then it's the producer of the packaging, how they produce the packaging. All of those are key links in this very long chain. Ironically, polymers, but but it is, and we're trying to talk to as many people as we can. But again, we're limited because we're restricted by the funding that's available to us. So the more money people want to give us, the better we can deliver an end product. Yeah,
well, I can imagine that the funding streams will get bigger for this, because it's a genuine, existential problem.
Yes.
It's not
we would hope
it's not
so.
A niche thing,
We would hope so.
Yes.
But we would like to be at the front of that queue rather than somewhere in the middle.
Right, I have one last question for you, which was, imagine somebody was listening to this and they were thinking about getting into research. They were late stage student, undergraduate student, or perhaps somebody who's already graduate but was thinking about getting into research. Would you have a piece of advice for them about any one thing that you think, that'd be worth doing? So, Adriana, we'll start with yourself.
I would give the advice of doing something that they enjoy. As I said before, I really enjoy doing research. I get great joy of looking at data and going like, oh, that's different, that's new, that's exciting. I really enjoy doing this. So for me, it's a pleasure to work on the lab, even if I have to stay in the lab late hours. This type of thing are things that make a difference when you are doing research at that particular, involved in a particular project. But more than that is to keep a mind open to what is that you are that is different from everyone else, and what is that you are that can add something to the scientific community. So if you want to do research and you have a particular interest, maybe you, at the moment, you might not be seeing, well, that particular interest that I have, it's not valuable or whatever. But if you join someone else, that particular thing that you have might be exactly what the other person needs, and that's where you kick off things. And then once research starts, it's more ideas, and ideas come. It's really, what do you have that might be missing in another research group, that might be missing in a specific project or a specific idea, and everyone has something special that they can come. I'm just thinking about a few of my students. We have students that come from all over the world. How interesting would be to join them in a project like this and see, okay, we saw the acceptability of the plastics in Ireland. What about in another part of the world? Maybe that particular student is the ideal person to coordinate that effort, or a person that has a particular interest in something that is made of plastic that is a big problem, and that person might be an expert on what are the characteristics that particular object needs that we can develop, with bioplastics. So it's really something that you like, that you enjoy, but also what do you have that might be an add-on to the scientific community.
David, same question to yourself. Piece of advice.
Yeah, I suppose same really. People who have a passion for project work and IoTs, SCTU has certainly it's founded on those kind of people. But like Adriana said, no idea is too small. So if you are somebody who's passionate about projects, but you think, but my knowledge is limited, that's not the case. As Adriana said, collaboration is such a key element of research. And you wouldn't go into research working on your own. You already have at least 2 supervisors who will help you to develop the ideas that you have. And I think conversation, if it is something that you're interested in doing or potentially interested in doing, talk to your lecturers, talk to people who are involved in research, postgrad students, and get their kind of opinion of what they think works. And I suppose to finish, the idea that research means you have to go into lecturing is not true at all. There are many, many researchers who have become entrepreneurs. And some of the support modules that Carlo deliver are about professional development and project management and that facilitates you on the other side of your career, so that when you finish your research degree, whether it's a master's or a PhD, you then have the knowledge and the acumen to carry that through to industry, to some kind of commercial concept, and so that there are. It's limited. Research is not limited to research. It's an opportunity to become a better version of who you are.
If somebody wanted to find out more about you and the work that you do, where would you recommend that they go? What should they do? So, Adriana.
I'm very good at answering emails, so email me at adriana.cunhaneves@sctu.ie, or you can find me on LinkedIn or ResearchGate or any of the more social media platforms there. The website for SCTU, you'll find my email, and I'm very good at answering emails, so I'll definitely come back to you.
Brilliant. David, yourself?
Yeah, I'd be the same. Just send me an email, and I'm happy to respond, whatever questions you have, or if you just want to start a conversation. That's the easiest way to get me. Trying to get me on office phone is very hit and miss, so I would suggest you don't go that route.
Excellent. Well, David and Adriana, thank you so much for speaking with me today.
Thank you for having me.
Thanks for listening to 9plus. Follow us on Twitter at 9plus podcast. That's digit 9 PLUS podcast. You can find me on Twitter at RobO'Connor_IRL, or you can email me directly on robert.o'connor@setu.ie. Thank you.